In Lesson 6.2, we'll understand how the file system hierarchy is organized. The file system is organized by the File System Hierarchy Standard, the FHS, which is a standard about how Linux file systems or Unix file systems in general should be organized. So if you go from one type of Linux, say CentOS, to another type of Linux, like Ubuntu or Arch Linux or Gentoo, there are some things that all of those systems will have in common thanks to this standard. So looking at some examples, we can use the tree command to look at the file system. And we'll just look at one level of recursion, one level of depth. We just want to look at root and the directories immediately off of root. And in order to do that, we can type this command, tree minus L1, and then slash. So this is showing us one level of recursion. So let's try to understand through the Linux file system hierarchy standard exactly what each one of these directories is for. The bin file system /bin is for essential commands. These are binary files, command files, that will always be available to you. No subdirectories are available in /bin. /boot, which we've covered in some detail before, is where the kernel itself is located and loaded from by the bootloader. It's generally a separate file system on the disk. In this case, if we type sudo fdisk -l, we can see that here. We have cgroup, which is for, it's a kernel abstraction. We'll ignore it for these purposes. It's not a standard. /dev is where device files are located. So if you had a CD-ROM on the system, it might be under /dev/CD-ROM. If you had a TTY attached to the system, well, all systems have a TTY attached, there's a file under /dev called TTY1 for the terminal 1, /dev/TTY1. These are device files, a special type of file. Etc is where configuration files are generally located, things to configure the system. /home is usually where user accounts are located. /lib and /lib64 are library directories where shared library files are located. A library file is reusable code by multiple programs. For instance, any system call or abstraction that many applications might need to be used, it wouldn't make sense for each type of application to write that code itself. So instead, they're put in a library, and many different applications can refer to them. Those are often stored in /lib and /lib64. /media is where removable media might be mounted. If I put a CD-ROM in my system or a USB thumb drive, it might be mounted in /media. /mnt is for temporary mounts. Opt is for optional software, where you might install something specific to your site or specific to your company or organization that might go under /opt. /proc is that pseudo file system that exposes kernel configuration and process information separately to the user from the kernel. /root is a special home directory for the root user. So note that the root user's home directory is not under /home like the rest of the user accounts. /sbin is for essential system binaries that only root can use. So these are sensitive binary files. We'll skip a couple of these that are not super relevant to the context at the moment. /temp is used for just storing temporary files. You can use it yourself as the administrator to do an experiment or copy files into temporarily. On some systems, like on Ubuntu systems, /temp is cleaned out at a reboot. So if you reboot the system, anything in /temp is removed, so don't put anything important there. On a CentOS system, I don't believe it is removed, but it's still not a good place to keep long-term files. /user is where shared read-only data goes. So you might find general user binaries or things installed specific to the distribution. The files under here will be very different between Ubuntu and Red Hat, for instance. /vagrant is Vagrant specific, of course. It's just where Vagrant mounts a shared directory with the host system. So if I went into /vagrant and list it here, I can see files that are also on my laptop are stored in this directory. So this is shared between the Vagrant system and my laptop. Finally, /var, which is sort of variable data files. If I look in var log, I see log files. We may recall from the previous lesson that under slash var spool cron is where cron tabs are stored. Sometimes databases put files here. There's also system lock files under slash var slash run. What we notice here is a number of .pid files. So if I looked at, for instance, var run cron_d.pid, it's only going to contain a number, 1274. And this is the process ID of the cron daemon, 1274. So in this way, a process can prevent itself from starting up twice. So what it will do is it'll try to start up. The first thing it does is look in wherever it's stored its PID file. If the PID file exists and it has a number in it, it knows, hey, there's already a process running. I'm not going to run again because I'm already running, and then it will just quit. That's a common use of a PID file. So that's how the Linux file system is organized.